This is Chapter 3 Mid-Chapter Review, specifically Lesson 3.1, Graphing Cubic Equations. So in review question number 1, it's asking you to graph f of x using technology. So I went ahead and graphed this on Desmos, as you can see. And what we want to do is we want to recognize all of the important parts or the key features of this graph. So right now I can kind of see that it's got this up coaster type pattern for my end behavior, but I need to get all of these things. Like I need to get the zeros and the end behavior, the intercept, the maxes and the mins and all of these things. So I need to kind of zoom in, and if you look right here, there's a lot of stuff going on in this little section. So go ahead and pop open your Desmos, make sure it's in the Tennessee State testing app, and graph it. And I want you to see if you can find all of these key features as well. So you can see, start out with your zeros here, here, and here. So you may want to write those down on your notes. Now if I adjust just a little bit, those disappear, and you wind up with, that is your relative minimum here because it's at the bottom of the valley. I'm going to write that down in a minute. If there's a lot of decimals, like I would just round it to 1 decimal place. That's the easiest thing to do. Go ahead and take note that your y-intercept here is at +2. And then if I scoot it a little bit more here, I can find my maximum or my relative max here. So I have a little bit of a head start. I went ahead and I plotted points at the relative maxes and the mins. I have my zeros here, and I have my y-intercept. I don't have any of them labeled because everything's kind of close together, but I have the generic sketch and the shape right here for you. So let's go ahead and write down all of our important points. So the zeros are at x equals -2.7, 1, and 0.7. Those are all located on the x-axis. I'm going to skip C for a second. We're going to look at the y-intercept. Your y-intercept is on the y-axis, so y is equal to 2. Your relative maximum was approximately at -1.5, almost a 7. And, oh, I should probably put max. And then your relative min was at 0.9 and -0.1. So now that brings us to all the parts that we have to interpret. So if we go back up here to part C, it says describe the end behavior. Now I talked about it the other day. Your graph is always going to go to the right, and your graph is always going to go to the left. You're always going to start out with those two directions. What you want to do is you want to focus on what your arrows are doing. Now this is the left arrow and this is the right arrow. As you notice, as you go to the right, you go up. So let me go back over here. So as we go to the right, we also go up. So these two have to be paired together. Doesn't matter what order you write them in, but they do have to be attached to each other. Now on the other side, if you look at your graph, it is left and down. So down would be y approaches -infinity. It doesn't matter which one you write first, but you do have to have those paired. You can always, instead of putting y, you can put f of x as well. So the next one's to describe the domain and range. This one's actually pretty easy because there's no limitation. This graph is going to continue to go to the left and go to the right, but it also goes up and down. So no limitations at all. That means the domain and the range is all real numbers. All right, last one is where is it increasing or decreasing? You need to read the graph from left to the right. This is the same increasing and decreasing in Chapter 1 and Chapter 2, so this is kind of a review. So if we're riding in a roller coaster or driving a car, you can kind of tell where you're decreasing and increasing. So what I'm going to do is I'm going to highlight in yellow my increasing. So I'm going up here, and I'm also going up here. Now notice that you have this kind of starting and stopping point. That's your max, and that is your min. And you've already found your max and your min, so that's going to help you write your intervals. So down, I'm going to color this in green. So increasing is yellow. I go all the way down there. So increasing, yellow, decreasing in green. Now I'm going to just take a little second here. Your maximum over here, that is negative 1.5. That's your x value. And your minimum x value is 0.9. And I only care about the x value because it's an interval. An interval always reads left to right, which are your x values. Okay, so increasing, that's going to start over here at the far left, which is negative infinity, and it's going to stop at negative 1.5. Okay, and then you start increasing one more time again at 0.9, and then you go all the way to the right, which is positive infinity. So you've got two parts or two intervals where you increase. So decreasing is that part in the middle. You start decreasing at negative 1.5 and you stop at 0.9. So question 2 is asking whether or not it's a polynomial or not. The way that you can tell if something's not a polynomial, if it has a fraction exponent or a negative exponent on the variable. So what you need to do is you need to look at all of the variables and the exponents on those variables. So it looks like all of them are whole numbers, and that's exactly what you want. So yes, this is a polynomial. So if so, we're going to write it in standard form, find the degree, the type, and the lead coefficient. So this is not in standard form, so we need to fix that. So we're going to write 1/4 x to the third minus x squared plus 7x minus 10. The degree is 3. It's going to be the highest exponent on a variable. It is cubic. That is the type. And your lead coefficient, that is the number that is multiplied to your x to the third in this case, would be 1/4. So it is positive. Negative 10. And it's that easy. So question number 4 is average rate of change, and so many people forget how to do this. All you do is simply use the slope formula, which you don't have to have memorized, but you do have to know how to use it. So the way average rate of change works is that it's going to give you a very specific interval. This one says it starts out at -1. So where is the graph at -1? It is here. So -1, 0. And +1, positive, and oh, it's way down here. So that is 1, -4. So you notice how I found both the x and the y coordinates? You have to do that. So I'm going to write -1, 0 and 1, -4. And I'm going to label that x1, y1, x2, y2. And the whole purpose of that is to, oh, that's terrible, is to figure out the slope of this line right here. Obviously, it's going to be negative. So I'm going to go ahead and plug this in. Got -4 minus 0 and 1 minus -1. Well, that's going to change into -4/2, which is -2. And that makes sense because that looks like that has a slope of -2. And we're done.